So now you see the other problem is given. It is just like what is the range of capacitance to be varied to get the required frequency values. So two inductance L1 and L2 are given. L1 is 2M and L2 is very, very small, 20 microhenry. And the frequency is varied from 950 kilohertz to 2050 kilohertz. So L1, L2 is given, F1, F2 is given. They're asking us to find what is the value of capacitor. So these oscillators will work only at one particular frequency. So first for 950 kilohertz, use the frequency of oscillation formula and find C. Then use 2050 kilohertz, use the same formula and find out the next value of C. So the range of C will be between these two values. So same thing we are going to do is use the same formula. First to write the formula. Here also nothing is mentioned about mutual inductance. So you can take M value to be 0. So F naught is 1 by 2 pi root of L1 plus L2 into C. So rearrange this equation and have it in terms of capacitance C. So C is equal to 1 by 4 pi square into L1 plus L2 into F naught square. So when F naught is 950, find out what is C, 13.89 picofarad. When F naught is 2050, find out what is C. C is 2.98 picofarad. And you can logically see as the frequency is increasing, capacitor value is decreasing. It is evident from the equation. F naught is proportional to 1 by root of C. So as the frequency of oscillation is going to increase, the capacitance value will decrease. So I need to have the capacitance starting from 2.98 picofarad to 13.89 picofarad for this application, whatever mentioned, using the Hartley oscillator. I told you this can be the example of a simple case where you are going to vary the frequency of an FM station and hear it from your mobile phone.